DIPPR places great emphasis on the accuracy of the data in the database. This video explains why accuracy is important and how inaccurate data can drastically affect the cost of chemical processes and units. Consider the design of a typical heat exchanger. One of the most important properties involved in such a calculation is the thermal conductivity, and inaccurate data can drastically affect the design and cost of the unit. Recall that the convective heat transfer coefficient is usually calculated from Nusselt number correlations like this one for flow through a cylindrical pipe. And it is directly proportional to the thermal conductivity of the compound. If the thermal conductivity used in the calculation is too high compared to the true value, the heat exchanger may be sized too small to give the needed heat transfer. If the thermal conductivity is too low, the heat exchanger will be larger than is needed, resulting in increased capital costs. Measuring the liquid thermal conductivity of a compound requires careful measurement techniques, and the literature is filled with inaccurate data for the property. The purpose of the DIPPR systems evaluation process, described in other videos, is to ensure that engineers have the most accurate data possible. Consider the data for this compound, an important chemical in the biofuels industry. A variety of experimental data from several sources have been published in the literature. Each color represents a different source. Notice that not all of the data sets are consistent. The data displayed as triangles don't follow the same pattern as the rest of the data. Through the DIPPR system's approach to evaluation, which includes evaluating the sources for the experimental data and also comparing the data to reliable prediction methods, such as shown here, it was determined that the data in the triangles were incorrect and were thus rejected. This rejected data had up to 55% error. So how would such an error translate into real-world application? One DIPPR sponsor recently put this in perspective when designing heat exchangers for a particular process. Historical values for the liquid thermal conductivity of one involved compound were off by 35% compared to the improved DIPPR values. Had the heat exchangers for the process been designed with the previous data, each unit would have cost approximately $40,000 more than was needed. Using accurate data resulted in significant cost savings.